For our next video, we're going to continue looking at rational expressions, and now we're going to multiply and divide them. So remember, a rational expression is just like a fraction. So to multiply, first you need to factor the numerator and the denominator. Then you're going to cancel out your like terms or your common factors that you have on top and bottom, and then multiply straight across. So for this example, we've got 2x squared plus 4x over x squared minus 4x minus 12. So I'm going to factor. Always look for your GCF first. So for the top here, 2x squared and 4x, they have 2x in common. So I'm going to take a 2x out, and that's going to leave me with x plus 2. On the bottom, it's a plain Jane trinomial, so I got to find something that multiplies to negative 12 but adds to negative 4. And so that's going to be 6 and 2, and then the 6 needs to be negative. Then I'm multiplying by x squared minus 9x plus 18 over 2x, and I can't do anything with that 2x. But again, I have a plain Jane trinomial on top, so I'm going to multiply to 18 and add to negative 9, so that's going to be negative 6 and negative 3. And now I want to cancel out anything that's on the top and the bottom. So I have a 2x and a 2x that cancel. I have an x plus 2 and an x plus 2, and an x minus 6, x minus 6. And then I'm going to take whatever's left and multiply straight across. Well, I have nothing on the top except for x minus 3 and nothing on the bottom. So that means my answer is just x minus 3. So you factor, cross out, and then multiply straight across. So for example 2, we have 6x squared plus 18x. Again, I can look for my GCF, which is going to be 6x. And that leaves me with x plus 3. And on the bottom, we have x squared plus x minus 6. And so I have to multiply to negative 6, but add to 1. So that's going to be x minus 2 and x plus 3. And then I'm multiplying with x squared minus x minus 2. So I want to multiply to negative 2 and add to negative 1. So that's going to be x minus 2, x plus 1. And then on the bottom, x squared minus 7x minus 8. So I want to multiply to negative 8, but add to negative 7. So that's going to be x minus 8, x plus 1. Then I just want to cross out anything that's on the top and the bottom. So I have an x plus 3, x plus 3, x minus 2, x minus 2, x plus 1, x plus 1. And then multiply straight across. So on the top, all that's left is a 6x. And on the bottom, all that's left is x minus 8. Alright, so for this one, I don't know what happens to my line here, but I want to multiply these. So on the left, instead of it being something where you factor, I have a bunch of monomials. But the same thing applies. If it has something common on top and on bottom, we can cancel it out. So for example, I have an x and an x that I can cancel, and then a y and a y squared would make that just a y on top, because 2 minus 1. And then I also have another y over here that I can cancel that one with. All right, then I have x to the 5th and x cubed, so that's going to make an x squared on top. And then I have the 3 and the 9, which the 3 becomes 1, and then the 9 becomes 3. And then I have 6 divided by 3 is 2, so the 3 goes away, and this one becomes a 2. And then 2 over 8 becomes 1 over 4. All right, then we just multiply straight across. So I have 1 times x squared times y squared times 1, which is just x squared, y squared. And then on the bottom, I have 4 and nothing else, so it's all over 4. For the second example, I'm back to having these rational expressions where I can factor. So to factor 2x squared minus 10x, I have a GCF of 2x. And then that's going to leave me with x minus 5. And then x squared minus 25, that's difference of squares, so x plus 5, x minus 5. And then x plus 3 I can't change, and 2x squared I can't change. So now on top and bottom I have the x minus 5, and I have a 2x and a 2x, which just makes this become an x because it was x squared. And then I multiply straight across. On the top all I have is x plus 3, and on the bottom I have x times x plus 5. And we can leave it like that. Remember, you cannot cancel unless they're the exact same factors. So even though I have an x on top and bottom, the top is x plus 3, so that does not cancel out with just an x on the bottom. Okay, to divide, whenever we divide fractions, we always have to flip and multiply by the reciprocal. Same thing applies here. So the first thing you do is flip it, and it becomes multiplication, and then we do the same thing we just did for multiplying. We factor, cross out, and multiply straight across. So for the first example, the first thing I'm going to do is flip. So we have 3 over x plus 7 times x squared plus 6x minus 7 over 8x squared minus 8x. Always step 1 when you divide is to flip. Then I can't factor 3 or x plus 7, so that can stay the same. But x squared plus 6x minus 7, I want to multiply to negative 7 and add to 6. So that's going to be x plus 7 and then x minus 1. And then 8x squared minus 8x, my GCF is 8x, and that leaves me with x minus 1. So the x minus 1's cancel, the x plus 7's cancel, and I'm left with a 3 on top and an 8x on the bottom. Alright, for our second example, first thing we do is flip. So the first one stays the same, and then I multiply by 2x squared minus 5x plus 2 over 2x squared minus 11x plus 5. Alright, x minus 5 stays the same. I have a GCF for 9x squared and 18x, and that's 9x. And that leaves me with x minus 2. Alright, and then over here, they're not plain Jane trinomials anymore. So now I've got to do bottoms up or reverse box. So if I change colors and come off to the side and do bottoms up, I have 2x squared minus 5x plus 2. Alright, move my a to make it part of c, so x squared minus 5x plus 4. And then to multiply to 4 and add to negative 5, we have x minus 4, x minus 1. Then I've got to divide by my a, so I end up with x minus 2, and then 2x minus 1, because I have to do bottoms up. So that's my numerator for this side, x minus 2, 2x minus 1. And then denominator, got to do the same thing. But now 2x squared minus 11x plus 5, multiply a and c, x squared minus 11x plus 10. And then to multiply to 10 but add to negative 11, it's x minus 10, x minus 1, and divide by my a. So I get x minus 5 and 2x minus 1. So x minus 5, 2x minus 1. Alright, my x minus 5's cancel, my x minus 2's cancel, 2x minus 1's cancel, and that leaves me with nothing on top, so that's a 1, and then on the bottom just 9x. So we get 1 over 9x. And then a couple more examples for division. So for the first one, I'm going to bring down the first fraction, and then flip the second one and multiply. So we get x squared minus 6x plus 8. Over x squared minus 2x. So I can't do anything with the 4x, so it stays the same. And then on the bottom, I have a GCF, so it's 5 times x minus 4. And then to multiply to 8 and add to negative 6, that's going to be x minus 4, x minus 2. And then GCF for the bottom is x, and that leaves me with x minus 2. So my x minus 4 is canceled, the x minus 2 is canceled, the x and x cancel, and once we cross everything out, I'm left with a 4 on top and a 5 on the bottom. So this whole thing simplifies to just 4/5. And for the last one, I'm going to flip the second one, but right now it's not written as a fraction. So remember, anytime you have just a number or an expression, you can write it over 1. So when I go to flip it, first one stays the same. And then I'm multiplying by 1 over 2x squared plus 5x. Alright, and this one I'm going to have to do reverse box or bottoms up. So 2x squared plus 3x minus 5, multiply a and c. Alright, to multiply to negative 10 but add to 3, it's going to be 5 and 2. So you positive 5, negative 2, and then divide by 2. So it becomes 2x plus 5 times x minus 1. So we have 2x plus 5 times x minus 1. Can't do anything with the 6x. Can't do anything with the 1. And then on the bottom of my other one I have a GCF of x, and that gives me 2x plus 5. Alright, 2x plus 5, 2x plus 5 cancel. On top, x minus 1 times 1 is just x minus 1. And then on the bottom, 6x times x is 6x squared. And that's as far as we can go.